I'm going to try and get through some of this today. This is going to be a multi thing. Oh, bam. Voila. I'm going to just do a quick refresh here. And so it looks like my group is probably quitting WoW. We lost our tank. Most important thing. There goes my dedicated raid knights. It's going to make this a lot easier going forward, but yeah, it's a thing. Okay.
Right? Unlinear is boring. Now, the way that you will be able to overcome those obstacles would be the mechanics. For example, here we could add a jump mechanic. With this little example, we have created a game flow. There is a start, and there is a finish. We can create more levels, add more obstacles, add more mechanics, but the flow of the game will be the same. We need to reach the goal. That's not a game, right? What is a game? A definition could be where you're in control of something, you need to achieve a goal, and something is preventing you from reaching that goal. Otherwise, it would be pretty linear, right? Unlinear is boring. Now, the way that you will be able to overcome those obstacles would be the mechanics. For example, here we could add a jump mechanic. With this little example, we have created a game flow. There is a start, and there is a finish. We can create more levels, add more obstacles, add more mechanics, but the flow of the game will be the same. We need to reach the goal at the finish point. So in order for our template to be a game, we need to add a way to finish the game. In our case, it will be the finish line. When our car crosses the finish line, then we can tell the game that it's finally over.
We're
We
not
will make this
actually
game a
going to
time
do
trial
that.
game. You will need to cross some checkpoints in order to stay in a race, and that will be the obstacle of our game. The mechanics, beside driving, will be that every time you pass a checkpoint, you will get more time, so you can finish the race. And that will be how our game will work. Let's start by creating the game mode, which will hold all the rules of our game. Let's create a folder called Racing Game. Inside it, a new one called Framework, and inside it, let's create the game mode. Here we have it. Click. Let's call it GM Racing Game. Inside it, we will define the states of the game. We will have the start of the game and the end. This is done by going to the event graph, right-clicking, and typing custom event.
We're not doing a custom event. We're just going to program it directly. I think this is weird. This is like actually what I was hoping for. Okay. Affected by engine. Oh. Okay. So if we're doing the sports car front, right, and rear wheels for the sports car. Be affected. Okay, so it's B. Sorry. Front. Affected by engine equals false. Then we want the rear wheel because this is the front, right? And we're going to split right. Let's bring this over here. Rear wheel by engine equals true. Then the affected by brakes equals true. Affected by brakes. Oops. No, bad pseudo. Wait, what am I doing, Lucifer? What did I do? What did I do? I don't know what I did. I did nothing. I did nothing wrong. I'm just driving a sports car, dude. This is not the car that I wanted. It handles better, but it's not the car that I wanted. The handling on this is fucking trash. How are things, by the way, Lucifer? Wow. Okay. Driving mechanics. Here we go.
Now our game has a start and a finish. We only need to worry about the obstacles that will be stuff that we'll be adding to the map later on, and the mechanics of the game. In this case, the mechanics, the most basic one is driving. The second mechanic will be to get extra time from these checkpoints in order to not run out of time and lose the game. We will be focusing now on that driving mechanics. To tweak that driving mechanics, we need to learn a little bit more about the vehicle that we can find here in Vehicle Template, Sports Card, and these are the vehicle assets that the class will use, like the torque curve and the wheels assets. If you want to do a deep dive on how to customize your vehicles, I recommend checking out this video by the good people at Unreal Engine. This video has a lot.
Yeah, I think this is actually what I wanted. Driving around exploring chaos vehicle.
Hi everyone, my name is Paulo Souza, and today we're going to talk about Chaos Vehicles. Chaos Physics is a lightweight physics simulation solution built from the ground up to meet the needs of next generation games. Chaos Vehicles is the feature set of Chaos used for vehicle physics simulations. At Epic, we have been using Chaos for a while. It replaced the legacy system from UE4 and comes with significant improvements in performance. In this video, we're going to go over some of the Chaos features, especially for four-wheel vehicles. We will start with the specs for the vehicle meshes, how to set up physics assets, as well as the basic settings needed to have a four-wheel vehicle working in Unreal. We'll also go over how to properly rig the vehicle suspension if you need that level of detail in your project, but also how to make your suspension animate in real time using Control Rig. In the end, we're going over some of the settings that affects car handling and different setups that can help you get to the experience you're looking for in your project. Before we start, let's quickly go over some of the important features of Chaos Vehicles. Chaos Vehicles provide more reliable simulation results. The system supports the async tick physics overview mode in Unreal Engine 5, which improves the determinism of the simulation and allows for predictable results every time the simulation runs. The new system follows a similar setup as the legacy vehicle system. That makes it easier for users who are familiar with the old workflow to switch to the new one. A vehicle is still represented mainly by a skeletal mesh and one of more wheel blueprints. A physics asset is still used to provide the appropriate collision geometry for the vehicle, and an animation blueprint is used to transfer the suspension and steering simulation to animate the wheels. The system now provides more flexibility to the user by removing the limits on the number of wheels it can simulate. A vehicle can now have any number of wheels, as well as any number of forward and reverse gears. Chaos has also experimental features for more arcade feel, like direct control over roll, pitch, and yaw torque. Now, let's see how to add a vehicle to our project using the wheel vehicle class. The most basic setup for any vehicle requires you have a skeletal mesh. After we import our skeletal mesh into Unreal, let's take a look how to set it up. The wheel vehicle class uses the skeletal mesh to determine the location of the wheels in our vehicle. The skeletal mesh can be as complex as you need, depending on your setup. But for this demo, we'll go with the basics and start with a 4-wheel vehicle that requires at least 5 joints, 1 root joint, and 4 wheels. It's best practice to make your joints align with X forward and Z up. It makes our life easier later when we're rigging the vehicle suspension. This also ensures the wheels roll on the Y-axis and steer on the Z-axis. Make sure that the joints are set in the proper scale when importing from your favorite DCC. Default scale should be 1 on every axis. Any other value may break the vehicle simulation. Next, we're going to recreate our physics asset. Let's delete the default bodies and start from scratch, so constraints are created correctly. In the skeleton tree, click on the gear menu and enable Show All Bones. Select the root node of the skeleton, and in the Tools tab, change the primitive to box and disable the Auto Orient to Bone checkbox. Click the Add Bodies button. That generates a body using the root and its child bones as the mesh bounds. We can scale and move it to adapt to our mesh needs. And we can also add custom convex volumes to our physics asset if needed. In the skeleton tree, right-click the body you want to add to the volume and look for Copy Collision from Static Mesh. Select the static mesh containing the convex volume you want to import, and it should just work. Now, let's select the 4 bones we're going to use for our wheels. In the Tools tab, let's recheck the Auto Orient to Bone checkbox and change the primitive to Sphere.
Do they actually give me these? Oh, they might actually do this. They don't. Of course not. Okay.
Create the new bodies and see the result. The wheel bodies were automatically created together with the necessary constraints. You can see the relations directly in the graphs panel and alongside the bones in the skeleton tree panel.
So
Let's
this
drop it
is
by selecting the
largely
wheel bodies
being
again.
done already.
We will change their collision response to disable. These bodies will never actually be used for collision since the wheels use a raycasting for interacting with the world. We're also going to change the physics type to kinematic, so all the wheels affect the vehicle bounce and shadows and culling occur correctly. Let's now create our wheel vehicle. Start by creating a new blueprint based on the native wheel vehicle pawn class. And let's give it a name we like. Then we're going to set the mesh to the one we have imported a few moments ago. And in the next step, we're setting up the wheels. To start, select the vehicle movement component. Then in the details panel, let's add 4 wheels to our wheel setup. For the first wheel, let's create a new wheel class asset and pick a name that represents this is the setup for the front wheels. Then let's go straight to business and change the axle type to front. Right below, we will find the wheel radius and width option. Before we view that, let's find out the size of our wheel. Let's go back to our main viewport and drag and drop our skeletal mesh into the world. Then press Alt-J to switch to the top view and zoom in one of the wheels. Drag the middle mouse button to use the Unreal Measure tool. So here we found that our wheel is about 24 centimeters wide with an approximate diameter of 64 centimeters. So back to our vehicle wheel. We're going to change the wheel width to 24 centimeters, leaving the wheel radius as 32, since it's half of our diameter. Increase the friction force multiplier to 4 to increase the traction on the track. And since this is
that
the
might
front
be
wheel,
nice. Okay, what was it? It was friction force multiplier. These are on the wheels. Do I even have wheels? I don't think that I have wheels. Fuck, what? No. Jesus Christ. Is this maybe in the
so the Unreal Measure tool. So here we found J to switch to the top view and zoom in one of the wheels. Drag the middle mouse button to use the Unreal Measure tool. So here we found that our wheel is about 24 centimeters wide with an approximate diameter of 64 centimeters. So back to our vehicle wheel. We're going to change the wheel width to 24 centimeters.
I don't think that they give you access to the wheel directly here. No, they do. Here it is. Oh, there it is. There's the wheel. And that's not really what I wanted.
Leaving the wheel radius as 32.
Car wheel front. Oh, wait. I know where this is. Here it is. There we go. Okay, so
since it's half of our diameter,
24.
Increase the friction force multiplier to 4 to increase the traction on the track. It's 32, since it's half of our diameter. Increase the friction force multiplier to 4 to increase the traction on the track.
Increase it to 4. We increased it to 3. What if I... Oh, okay, I see what they did here. The rear wheel, because it's a rear wheel drive, right? To do. Okay. Brake torque. Do I even have a handbrake? Where's my controller? Player controller, here it is. Unpossessed, tick, begin play. Where's my controls? Oh, this is new and interesting. Okay, so the mapping gets automatically done? Handbrake. Spacebar is handbrake, okay. Brake is S. Reverse is also S. Throttle is up. Okay. I guess. Okay, so I want to get to the steering radius here.
And since this is a front wheel, let's enable the affected by steering checkbox and configure the steering angle. Compile and save this blueprint. Now that our front wheel is saved, let's configure the steering angle. Compile.
Max steer angle. Oh, I think this might be it. What did they update theirs to? 40?
Track. And since this is a front wheel, let's enable the affected by steering checkbox and configure the steering angle. Compile and save this blueprint.
Let's say 50. At least I know where I need to, like, fuck with these things. Okay, I need to figure out the weight of the vehicle. Because they shouldn't go flying like this. I almost don't want to... Like, I almost wonder if it would be worth it not to use the chaos system at all. The physics might be nice to have on a separate thing, and the issue with the... Wait, what's going on here? Okay, I'm not turning. Oh, interesting. If I start steering right, I just keep going a little bit more right. No? Unreal doesn't support vehicles. I'd imagine there's a reason that it doesn't. Rocket League is a vehicle-based game that runs on UE3, and it's getting moved to UE5 in the future. It's because they have their own engine, a lot of engine programmers, and do not... So games use proprietary... I can answer this. I made a good bulk of vehicle systems on Squad along with the rest of the team. I left in 2017, but they continued a good amount of the work. We created an N-wheeled vehicle system in order to support large vehicles. Overall, UE4 has a vehicle system, but it's not that great. It's not that great as others have pointed out, although Squad implementation was later put into a plugin, the enhanced vehicle plugin. That's actually what I was going to think about using. As for the games you mentioned, they don't use UE4/5 because the engine they do use built in-house. Big companies like those make their own engine. If you don't want the wheel to go into the ground, the exact size of the wheel and the... Huh. Okay, not that. Okay, so... I've looked across the internet on the channel to show what to use. Any thoughts on this topic after a year? Yes, don't use advanced vehicle system if you're planning destructible vehicles. The skeletal mesh lag behind at high speed. I'm planning to implement my own lightweight vehicle system or just use default Unreal template. I can bear the trade of semi-realistic suspension of AVS for simpler vehicle base and destructible vehicle bodies. Sorry for the old post. What made you not use in this case and move to your own lightweight system? I went with this asset set as it worked well with my wheeled vehicles as well as tracked tanks. I see it's now not for sale. Wait, is it not for sale anymore? Interesting. Vehicle movement component. Just realized there's two different assets. We use both. Sorry, I'm just getting an idea for this. Interesting. It's gone completely. Enhanced vehicle plugin. Interesting. Okay, well, whatever. We're going to keep trying this one, and we'll see.
Now that our front wheel is saved, let's make a copy of it to be used for our rear wheels. Let's change our axle type to rear, and enable the affected by engine checkbox, so this wheel can be driven. It's also important to prevent this wheel from being affected by the vehicle.
Vehicle pawn to do. This is no longer a thing. Cool.
Steering. Then compile and save. Let's get back to the wheel setup and drag and drop the rear wheel config file we have just created into the wheels index 2 and 3. Then we can proceed to configure the actual wheel locations. For that, we're going to
Wheel setup. See, I'm not sure where some of this is. Because, okay, I'm just going to have to be lost for a little bit.
set the bone name parameter on each wheel to a bone in our skeletal mesh. You can input the bone name manually or easily copy it to the clipboard. Next, we input the bone names from our skeletal mesh representing the wheels in our car. You have to pay attention here to use the exact bone name and the right wheel class. The next step is to configure a torque curve for this engine. For that, let's click the Create External Curve button and then save our new curve asset to the proper folder. Open that curve and use the middle mouse button to create new points. Set their values to 0.5. Set the last point to 5,000, which is our vehicle max RPM. Then press F to frame the curve. Let's add 2 more points. And our final curve should look like this. Like we did in the torque curve, let's proceed to update our max RPM to 5,000. We are almost ready to drive this car. Let's accelerate it using the set throttle input method from the movement component.
I want the turning radius
But before we play
to be
it,
better.
we need one more thing. We need to enable simulate physics on our mesh for it to work. So back to the viewport, let's finally add our vehicle pawn to the world. To quickly test this, let's override the player pose as to player 0. Press play and voila, we have a moving vehicle. Although it doesn't look great, but we'll fix that. Let's get back to our vehicle pawn and add a spring arm and a camera. Pick any setup you like here, but we found that a distance of about 600 units works really great for a third-person camera. Also feel free to map your input as you need. We're only going to need mappings for throttle, steering, and braking. And we can move on to assign your inputs to the throttle, steering, and braking methods of the vehicle movement component. If we play it, we can now accelerate, brake, and steer our vehicle. But the wheels are still not properly animated, so let's fix that. Let's right-click our skeleton asset and create a new animation blueprint. For our car suspension visuals, we're going to use an extended version of our skeletal mesh. This upgraded mesh has more geometry and bones representing different parts of the front and rear suspension. Let's start by creating a control rig. Right-click on your vehicle skeleton and select Create Control Rig. But before we make a rig, we need to configure our animation blueprint first. Let's open our animation blueprint and add a control rig node right before the output node. Right, so let's fix that. So let's set the aim axis to -y. Now we're going to get our vis wheel bone. and set the aim target, so we will look at it. We want to use a Chaos Vehicles. We still need to copy that setup from the left wheel to the right wheel. The easiest way of doing that, the most basic thing you can change to affect your vehicle handling is the center of mass. You can visualize that in real time using a console command, but more on that later. As you can see, this vehicle currently sports a high center of mass. That directly affects traction, as there are moments the wheels stop touching the track. This is why cars in racing try to have the lowest center of mass possible. If we enable the center of mass override and set it all to 0, we will find that the car suspension doesn't behave very realistically.
Okay, so yeah, I was right in doing this before. The turning's much better, but I'm really slippery now. I almost wonder if the center of mass is a bit too far back. I'm definitely too light. But let's say -15. Oh, fuck yeah. There we go. This turns a bit tighter. One sec. Okay, we're gonna set this back to 0 and see how how does 0 feel? Fuck, I really want to do this. The only downside of doing this with a controller is that I have to unplug the controller every time I frickin' build the project. Okay. No, that's the same. Oh, interesting. Yeah, no, it doesn't work. What's up, Chris? Okay, let's lower the center of mass to -10. No, Z is up. Oops, -10. We're tweaking center of mass to try and make this feel better. I'm gonna give them a bit of a lower center of mass, and I think this might make the game feel a little bit better. I still have like, oh wait, I know. Save all. Oh, thanks. It's on Reels. Hmm. Unreal doesn't like have um when I have the controller hooked up and I build the project. So every time I build the project, I've got to unplug the controller. Or else my car will steer one side. There we go. Okay, definitely not the handbrake. Ugh. I need the downward force, I think, to be a little bit more. Like it handles so bad at like slow speeds even. Well, it's not actually slow speeds, but so we're just going to continuously adjust the center of mass right now. Okay, so if we bring this back, -25, let's see how well it handles now. Okay, so the brake entirely just shuts off everything. Like the second that you brake, you can't turn. um hmm. That's kind of it right there, right? You streaming in YouTube? Yep. Oh, I'm absolutely not rocking. Four-wheel drive. I guess it would be pretty back heavy, right? Jacking the planet. Well, definitely not jacking the planet. Save all. Okay, we're gonna rebuild. I still hate that I have to unplug this fucking controller every time that I want to build this project. Actually bothers me. So being sexy, that is cool too. Yeah, I suppose. All right, let's plug this controller back in. There's the rumble. there's that. Okay, beautiful. This feels a little bit better, I think. Look at that though. Okay, so the center of mass is weird. Probably because of how light the car is. Yeah, I gotta make this car heavier. How have you been, by the way? I want to make it heavier. Well, adjust the center of mass. I'm just like, but I don't want to adjust the center of mass. I actually should adjust the center of mass though. But I do actually want it to be heavier. I'm at work? You're at work? I hope that you're having a good day at work. Okay, let's go back to here and see if they give us anything else.
So let's try to offset it to 50 units on the z-axis. It works better now. The car still rolls, but not to the point of lifting the wheels from the terrain. You can also try offsetting the center of mass vertically. That will affect the overall dynamic of the car in corners, but more of that in the next topic. Vehicle dynamics in cornering are usually the most sensible aspect of car handling. The friction multipliers are super effective to calibrate our cornering dynamics. You should always start with it first, and then move to other wheel parameters for fine-tuning. Let's try to run some tests and see how understeering and oversteering affects cornering. A friction factor too high on the rear wheels makes it harder to take this corner. Our car is clearly understeering. If we reduce this factor to 0, we risk having too much grip on the front wheels. That may be disastrous for our corners, especially in a rear-wheel-driven car.
There
the
we
ideal
go.
setup is the one that finds the right balance between understeering and oversteering. Most times, it's usually a bit of both, and both should help the vehicle take corners the most efficient way. Keep in mind that
Okay. 4, and they're suggesting 4.5. There we go. I don't like this at all. I have an idea though. Might actually have to build more of this game in frickin' blueprints, and that would be so sad. Because every time that I have built this in C++, it causes problems. As in, my car turns. Do I know why? Nope. Oh my god, that feels so much better. Still doesn't take that turn very well, but oh my... I think I need to adjust it even more. Where is the wheels? Downforce. Huh, okay. Downforce is good. And take this turn a bit better. Yeah. Okay. I don't fly all over the fucking place anymore. Oh, sweet. This is okay, so that it was the down it's the downforce that I needed to adjust, I think. Okay, so downforce of 2 instead of 1. We were just at 1. We're going to see what 2 feels like. Because we started at 0.3 and I was just like 0.3 doesn't feel good. That's still better. Okay, so 2 maybe not enough. Let's crank this up to 10. I'll put this out on itch once I get it to feel right, so we can kind of like collectively take a look at it. This feels better. Ugh. I'm definitely getting there. Ah, okay. Yes. Let's try this. If true. We're gonna see if this makes a difference. What's this gonna do? Because what we want is we don't want to fly all over the freaking place every time we hit something. And I downward force does make a difference, but like we didn't fly, which is nice. We still fly there. Maybe it is just more downward force. Because every time I adjust the downward force, it works and so far. So we're going to try that. We're going to reset that to 0. And this we're going to go to 50. So downward force is now set to 50. Let's try this out. This could be good. Or it could be horrible. Oh, oh. It's starting to feel a little bit. I think steering's a bit too all over the place here. So maybe 40. It steers a little bit too well at high speeds. That feels better. We're gonna also have to affect the braking because I think the braking's too damp. Huh. Huh. I'm getting better at this. This is getting better. I think this is, it might be a suspension thing though. Let's try tweaking the other one as well while we're at it. Off-road. This feels a little bit better, but I think it's not actually what we need. And I think this can be tuned a bit different. Because this was at 1. Let's at 0.1. Let's take this to actually 1 and see what happens. Because I think that was a bit too aggressive for this specific vehicle. Yeah, this doesn't... I think this has a bit too much, and I think the car actually is a better spot. Yeah, I think the car is a better spot. So we're gonna just stick with the sports car. All right, so the sports car is at 40. I think that's a suspension problem though. Yeah, that's got to be a suspension. What are our suspension options? Oh. Is it here? Wheel friction enabled. Legacy wheel fix. Oh, this is nice. I see how this works now. And I feel less stupid. So we need to tighten up our suspension. Or loosen up our, no, tighten the expansion.
That this is a simplification, as there are many other parameters that affect handling. Differential types, the balance between front and rear brakes, engine torque, and the gear ratios have a big influence in dynamics. The wheel's slid and skid thresholds and the cornering stiffness can also be used to find
These are not at all there. But this is on the wheel itself. Co-lurk. Wait, co-lurk? What do you mean by co-lurk? Somebody else saw it? No, not that I can see. Okay. Corner stiffness. $1,000. Oh, look at that. Sure. Is this all of them or just the front wheels? Oh, here we go. Why is this being weird? We're gonna see how this works. I would probably try and package this and get this out uh, into people's hands so we can play with it a bit in the next, like, I don't know, month or so. So we can drive the car together and find out if it's terrible. But I gotta set something up so we can actually drive it. What the fuck am I hitting? Wow. That felt weird. Oh, you know what? It's too much downward force. Let's say 10 on all of these. Or sorry, minus 10. Hmm. I wanted to skid and stuff like that. Just nothing. Look at that. You still going fast enough? There's no air here. The downward force is too much. It's way too much. Okay, so we're gonna just come back to here on all of these. Save compile. We're gonna go downward force. We're gonna say 5 maybe. Oh, I was hitting the space bar by accident. Still need a little bit. I think we still need a little bit more. Actually, no, that could have been like a little bit, like a feather of a, like that. Okay, so that's actually a problem. But some of these, even when you're going really slow, you still can't take these turns. Or I guess like taking this turn at like above 100 is kind of ridiculous. I think this is a post-processing thing where we gotta tie the speed to a feel, because it doesn't feel like you're going fast, even though you are going kind of fast. Actually, what is 100 kilometers an hour? Like, no, that's not that bad. Actually, yeah, 140, 150 kind of is to be taken a rather sharp turn at. So I think I can get behind this. I think I got to make it feel different though. Okay, so I think the car mostly feels good now. How does it take jumps is the next question. There we go. Look at that. Okay. I think we're good here, but I want it to not frickin' fly off the handle when it hits these. Yeah, but I didn't find a weight option. If I do... What's this do? Oh shit, that was it. No, it was not. Ugh.
Welcome back everyone to another Unreal Engine 4 tutorial, and in today's video we will be talking about some settings that was a weird camera angle, about the gearing, about the mass of the vehicle, the traction. As you can see, I have super high traction. My center of mass is at the very rear end of the vehicle, so it is super simple for me to do a wheelie on this guy right here. So yeah, if you are interested in knowing how to adjust the gearing, suspension, how does the center of mass work, and the vehicle traction, then this video is for you, and let's get started. So let's start talking about some settings. So if we would press play on this, well, you can see our vehicle is very bouncy, and if we would try to overcome this obstacle course, well, we got stuck on that one. I made that one too big. But if we go to a little bit of a smaller one, you will see that our wheels are extremely bouncy. And obviously, if you are making like an off-road vehicle with large suspension, that might do the trick. But in our situation, if we want to make like a drift car or a race car or whatever, well, this is not exactly what we want. Also, you can see the wheels are turning super fast because they are the ground is super slippery for these specific tires, and the traction is just simply not there. So first, what we can experiment with a little bit is our actual suspension settings. So for instance, while we are in the game, we have this widget on the right side of our screens. If we use a shortcut Shift F1, it brings up the mouse like an Unreal Engine it does by default, and then we can change some values. So for example, right now our wheel travel is at 15. That is very, very high. So let's set this to something like 3. And now if we would try this again, you will see that our wheels are no longer jumping and moving as much. Obviously, they're still moving because they have quite a bit of travel available to them, but we can again lower this to something like 1. And then if we go across this section once more, now they're moving a lot less. So a few more things that we can do is increase the shock absorption, so something like 10. Let's set like spring strength to like 300 and downforce something like 50. Now our vehicle is going to be super.
Oh, this is the plugin though.
Hi everyone. In the last video we talked a little bit about things like acceleration and top speed. In this video I want to focus more on the actual handling of the car, so things like steering and forward and lateral friction and stuff like that. One thing I did was I actually added these walls here. The reason for this is that I find that when you're tuning things like handling, it's a lot easier to get a good feel for it if you actually have some frame of reference. So just adding a few of these walls can be useful. And another thing I want to point out is that this is kind of the more subtle area of tuning. So a lot of this you'll really have to just play around with yourself so you can get a feel for it. Or I'll exaggerate the values just so that you can see the effect. But it's really, this is one of these things that designers spend hours on trying to get just right. So to keep that in mind. The first thing that I want to point out is you might notice if you hold the acceleration button, so I'm just accelerating the whole time, and then I start turning left, and then I let go, but I keep accelerating. The car totally steers out of control. And the reason for this is that I'm actually using an all-wheel drive car. So if you go to your car setup and you look up differential, you'll see that we're using limited slip four-wheel drive. There's a lot of different advantages and disadvantages to all these. I'm not really going to get into it, but the reason why it's looking like that is that as you're turning, you're accelerating, and you're actually getting power from the front and the back. So for the sake of the tutorial, I'll just keep it a bit simpler. I'm going to use front-wheel drive, which has a more...
This I think is too old.
Fine-tune cornering, as well as the suspension height, the stiffness, the roll bars, and the spring and the damper rates. All these parameters contribute to the vehicle dynamics. So we really recommend to start with a simple framework and then go from there. It requires some try and error, so avoid changing too many parameters at the same time. And the vehicle debug commands can actually help you visualize what is happening within the simulation. That's what we're covering next. There are 2 debug tools we can use to help us calibrate vehicle handling. The legacy debug mode is accessible via the show.
I'm not gonna lie, I'm feeling a bit sick right now. I think I'm gonna call it a day. I know I didn't stream for very long, but oh my god, do I ever feel like trash right now. I will catch you all later. Sorry for the short stream. Ta-ta for now.